All right, Integrated Math 3, this is lesson 3.02, and it's on rational equations. So in the first lesson, 3.01, we talked about rational expressions. So an expression is simply anything that's made up of as a fraction, like 4 over x plus 2. Just a simple fraction, 1/2. 1 over 2 is a rational expression. It's anything that can be expressed in a fraction form. An equation actually inserts an equal sign between two rational expressions, and then you solve. So now with an equal sign, we can actually solve for x. We can actually find an actual value for x, which again we're calling a root or a solution, or also a zero is something else that we can call that. Okay, so how do we do this? First of all, I'm going to write the entire problem over here so as not to work on the original here. So a little more space here. Okay, so the way to do this is to get rid of the fractions. And how do you get rid of a fraction? You multiply through by the denominators on both sides. I'll show you a way to shortcut that a little bit in some of the later problems in this assignment, but for right now, what you do is you multiply the top over here by x plus 2. Okay. And the overall rules of algebra say that you can do anything to one side of an equation as long as you do the same thing to the other. So I'm going to multiply this side by x plus 2. Okay, as long as I do the same thing, I keep that equal sign in balance. So what that does is this cancels out with this. And what that leaves me down here is, all right, now I'm going to multiply both sides by 3x. And when I do that, the 3x here and here cancels out. So now what I have is I have an equation that doesn't have fractions in it like that. So it's going to look like this. I'm going to put the 9 out in front of the x times 2. That's just switching places. You can do that with a multiplication like that. These traded places, that's perfectly fine. And I'll go ahead and simplify this, 12x. Now I'll simplify this. So it's 9 times x is 9x. 9 times 2 is 18. Equals 12x. Okay, and what we're trying to do is isolate the x. Just get x equals something. Okay, whenever you're trying to solve, you're trying to end up with x equals something there, some number. Okay, so if I look at this, I can either subtract 9x from this side or 12x from this side. I'd rather subtract the 12x because I'd rather subtract the 9x because that'll leave me with a positive number for x. You want your x to be a positive number. So I'm going to rewrite this over here. Okay, so I didn't change anything from there to there. So in other words, what I'm going to do is subtract 9x from this side and 9x from this side. This goes away, it becomes 0. And then the 18 is still there, positive 18. Then 12 minus 9x is 3x. If I subtracted the 12x from both sides, I would have ended up with a negative 3x over on this side, and that's not what I want. All right, so, and don't forget the equal sign still goes there. So 18 equals 3x. Divide both sides by 3. This cancels, and your final answer, and 18 over x equals 6, so x equals 6. Okay, and that is that's the answer to that. Okay, so this again is called a root or a solution, okay, or a zero, any one of those. Notice we don't have to find excluded values because there are not different values that x can take on the way there is in an expression. This is an equation. You're going to find a specific value for x. There it is. So you don't have to worry about excluded values on these types of problems. Okay, let's keep going. And I'll just write and you can watch, and I'll just fill in the details here. So let me I'm going to copy this over here. Okay, so copy this over there. Check, be sure you copied it correctly. So now I'll do it again in two different steps. I'm going to multiply both sides by x plus 2. That's legal in math. You can do that. Anything you do to one side, you do to the other. These two cancel. Go ahead and wrap the x minus 3 in parentheses. on this side we simply have x now. Okay, now we're going to multiply both sides by x plus 5 on the top. Okay, so the only thing I simplified there, I multiply by x5, so this cancels. You have those two. On this side, I went ahead and expanded that out to x squared plus 5x because it looks like we're going to get a quadratic there. So now I'm going to expand this out. I'm going to FOIL this. So x times x is x squared. X times negative 3 is negative 3x. 2 times x is positive 2x. That's going to give us negative 3 plus 2 is negative 1x. Just write that as negative x. And then 2 times negative 3 is negative 6. And on the right, I already wrote this, so I'll go ahead and put that again. Okay, now you want to get like terms, what they call like, L-I-K-E terms, with the same exponent, in other words, on the same side. So what I'm going to do is I am going to, it doesn't matter which way we do this, I'm going to go ahead and subtract x squared from both sides. Now in this case, it turns out it makes it just disappear. It goes to 0. So it disappears. But it might not have. You might have been left with an x squared term, but we didn't in this case. Okay, so now I have negative x. Let me go ahead and just write step by step what I have. Now I have negative x minus 6. Notice that's not in parentheses, so it's negative x minus 6. There's no parentheses there. And over here I have plus equals 5x. Okay, so this basically went away, this went away, and I'm left with that and that. Okay? Alright, now I'm going to add x to both sides. So negative x plus x goes away. Rather than writing zeros down there, I just cross it out. It goes away. Then you have negative 6 left there, and then 5x plus x is 6x. Divide both sides by 6. That, and that cancels, and this negative 6 over 6 is negative 1 equals x. What you can do, again, if you want to check work, you can always take an answer like this and plug it back into the original equation. Let's see if that works. Let's see if x equals 1 equals negative 1 works. So negative 1 minus 3 is negative 4. I'm just going to write it lightly up here. Negative 1 plus 5 is positive 4. Negative 1 here would be negative 1. And negative 1 plus 2 would be positive 1. So negative 1 over 1 equals negative 1, and negative 4 over 4 equals negative 1. So yes, negative 1 works when you plug that into the original equation. When you plug that in. So there's your answer. All right? Okay. Let's keep going. Okay, solve the equation. Okay, so we need common denominator. These two already have a common denominator. This one, so what you have to do is make all three of them common, the same thing. And what we're going to have to do is find the lowest number that all three of these will divide into. Think about that. What's the lowest number, the smallest number that all three of these will divide into? The answer is 6. 6 goes into itself one time. 3 goes into 6 two times. So let me go ahead, come over here, and write this out. I'm going to leave space in between them so I can write numbers down. Okay, so the smallest number, they're all three. So we need a 6 in the common denominator, okay? 6, we need to get these to be 6s. So the way we're going to do that is we're going to multiply this by a 2 on the top and the bottom. We're going to multiply this by a 2 on the top and the bottom, okay? All right. So what that's going to give us here, let's simplify this. It's going to give us 2 times 2 is 4. Again, it has to be top and bottom. You don't want to change the value of 2 over 3x. If you multiply by 2 over 2, effectively you're multiplying it by 1. 2 over 2 equals 1. You can multiply this by 1 and it still retains its original value. Even though it's going to look different, it's going to become 4 over 6x. 4 over 6x is 2 over 3x, so you didn't change the value of it. It's the same thing. All right, now, plus 1 over 6 equals 4 times 2 is 8, and 3x times 2 is 6x. Okay, so now we have a common denominator there and there. And the 6 that we needed to have is in all three of these. So the only thing we need to have for this one is an x. Once we have an x there, then they'll all have a denominator of 6x. Okay, so I got a 6x there and a 6x there. That's what I need. I need to get an x here. The way I can do it is multiply the top and bottom of this one only by x. Alright, so now I have 6x, 6x, 6x. Everything is good. So let me rewrite this. It's going to be 4 over 6x plus. Alright, so now that I have a common denominator here, I can ignore the denominator here. I'm trying to find the value of x. And so all I want to look at up here is the numerator. So I'm going to come over here. Because whatever x is, if I divide everything by 6 times whatever that number is, it's going to change everything the same. So we can ignore the denominator, just look at the numerator here. So 4 plus x equals 8. Subtract 4 from both sides. This disappears. 8 minus 4 is 4. And on this side you have x. So your answer is x equals 4. And if you're not sure, go back and test it out. 2 over 3 times 4 would be 2 over 12. And I can reduce that to 1/6. So I'll do that. 2 over 12 is 1 over 6. Plus 1 over 6 equals 4 over 2 times, over 3 times 4, excuse me, there's 4. 3 times 4, 4 over 3 times 4 is 4 over 12. That equals 1/3. 1/6 plus 1/6 equals, I'll write it over here, 2/6, which equals 1/3. So I get 1/3. I get 1/3 on this side, 1/3 on this side, so they equal each other. So that 4 is the correct answer. Okay, so notice a little trick here. Once you got the common denominator, you could ignore it. You didn't have to work it in this equation up here. You just took the numerator, the top, and came over here and solved for x. You didn't have to worry about the denominator anymore. All right. Okay, same thing here. So you've got these two, common denominator there and there. You need a common denominator over here. This one's pretty straightforward, so let's copy the problem. Again, when you do the copy, leave space in between for those multiplications of top and bottom that we've been doing. Alright, so we already have a common denominator there. We need a 5x on the bottom of this one to make it a common denominator for all three. So we're simply going to multiply top and bottom here by 5x. And there we have it. So now that we have a denominator, a common denominator, we can solve the numerator and not even think about the denominator anymore. We can solve for x. So I'm going to rewrite just the numerator. Now be careful with negative sign here, okay? So it's x minus 5 minus, I've got to put this in parentheses, x minus 3, because the negative is all of this entire term. And then over on this side I have just that 5x times 1 is 5x. Okay. So let me get rid of this negative sign outside the parentheses. So I'm just going to do that in one step here. Minus x, and negative is plus 3. Okay, so you had to remember to put the parentheses around that. That negative applies to both the x, but it also reverses that negative into a positive. Be careful then. Okay, so let's simplify anything we can before we start switching sides here. Well, x minus x immediately goes away. X, I'm xing it out with an x. I probably should put a light line through it. Let me do that a little more intelligent way here. So I have an x here. So this is going to go away, and this is going to go away. X minus x goes to nothing. Negative 5 plus 3, I think you can kind of do that on your own, so that's negative 2. So we've simplified this side entirely. That equals 5x. Now we need to solve for x. You divide by 5. Cancel and cancel, and you have x equals negative 2/5. Okay, and that's your final answer. If you want to check it, you can plug it back in. It's a little messy because it's a fraction, but you could plug it back in to get that answer. Okay, just 2 more problems on this assignment. This one will be pretty much like the last one. This one will be a little bit more work, but we'll get through it pretty quickly. Okay, so common denominator, but this one doesn't. So we need to get an x minus 1 underneath this. So we're simply going to multiply. We're going to rewrite everything over here. Okay, so now we're going to go ahead and just multiply top and bottom here by x minus 1. Okay, and once you've got common denominators, you can ignore the denominator. Why can you ignore the denominator? Because once you solve for this up here, if you divided everything by this same thing, they would all come out the same anyway. So you can ignore that. So we can just simply write this. It's 1 times x minus 1, which is just x minus 1. You can get rid of the parentheses because that sign's not going to get flipped. Okay, so now it's just simplify. So 1 minus 1 just goes away, right? 1 minus 1, 0. So we end up with our final answer right away. X equals 6. Let's test it out. 6 over 6 minus 1 is going to be 5. Now that's kind of a messy number. So 6 over 5 equals 1 over 6 minus 1, 1 over 5, plus 1. Well, what is 1 in terms of a denominator of 5? How could I express 1 as a fraction? With a 5 as the denominator, it would simply be 5 over 5. Okay, are you okay with that? 5 over 5 is equal to 1. So I just called 1 5 over 5. That's legal. So 1/5 plus 5/5 equals 6/5. So this is true, so that verifies that that is the correct answer. Okay? All right, let's keep going. All right, now this one's going to get messy. Now these two are exactly the same, fortunately. So to get a common denominator here, one thing I suspect we would be able to do is factor these. So you might want to do that or you might not. Sometimes you got to try a problem 2 different ways. We could multiply the top and bottom here by this entire polynomial, and then this fraction here would have that in the denominator. Then we could multiply these two top and bottom by this binomial, and you'd have that one over there. And you'd have a common denominator. You just multiply the things that don't have something, like these two don't have this, or at least it doesn't appear they do. I'm going to hold off on that. So you can multiply this and this top and bottom by x plus 8, and this one doesn't have this, so you can multiply top and bottom by x squared plus 3x minus 40. You'd have common denominators. But, usually there's an easier way on these types of problems in math class. So what we're going to do is we're going to take this and factor it. These two are the same, so we're going to factor this. So I'm going to come over here, x squared plus 3x minus 40. So again, there's a coefficient there of 1. 1 times negative 40 is negative 40, so we need to find two numbers that multiply to negative 40, and they're going to have to add up to the number in the middle, which is positive 3. Okay, one of them has to be positive, one of them has to be negative if they multiply to a negative number, and the bigger of the two has to be positive. So we're going to start with negative 1 and 40. Negative 1 plus 40 equals 41. That's not what we're looking for. We need 3. Negative 2. Negative 2 times 20. Negative 2 plus 20 equals 18. Not what we're looking for. Negative 3. 3 doesn't go into 40. 4. Negative 4 times 10 equals negative 40. Negative 4 plus 10 equals 6, not what we're looking for. Negative 5. Negative 5 times 8. Negative 5 times 8 equals negative 40. Negative 5 plus 8 equals 3. Those are the ones we're looking for. So it's negative 5 and negative 8. So since the coefficient there is 1, it's an x, and then whatever this number is, negative 5, x minus 5, and positive 8 plus 8. Okay, so now what we're going to do is rewrite this entire equation and we're going to replace these with this. So here we go. Okay, there we go. We just substituted these for the factored form of these equations. Now what you notice is now that it made our life a lot easier. They now all have an x plus 8 in the denominator. So the only thing that this one over here is missing is that x minus 5. So we're simply going to multiply the top and bottom by x minus 5. Okay? There you go. Let me put everything in parentheses down here. Okay, so now everything has a common denominator. That means you can work the top and forget about the denominator. So what do we have on top? We have 5 equals 1. And then it's 1 times x minus 5, which is x minus 5, but it's minus. Be careful. You got to put the x minus 5 in parentheses there, because that stays together. So I can simplify this a little bit more by just calling it 5 equals 1 minus x. And then this is a negative makes it a plus 5. You got to be really careful on that, okay? All right, so now it's pretty easy to simplify this. We're going to subtract 5 from both sides. That goes to 0. And that goes to 0. So these go away. So now you simply have over here 0 on this side equals 1 minus x. That's the only thing left on that side. So let's add x to both sides. And this goes away, minus x plus x. That leaves you with 1, the equal sign, and 0 plus x is x. So there's your answer. X equals 1. Let's check it out real quick. 1 squared is 1, plus 3 times 1 is 4, so 3 times 1 is 1. 3 times 1 is 3, so 1 plus 3 is 4. 4 minus 40 is negative 36. You have 5 over 36. Okay, again, 1 squared is 1. 3 times 1 is 3. 1 plus 3 is 4. Minus 40, again, is negative 36. So you have minus 1 over 36. Okay, and 1 plus 8 is 9. 1 over 9. So 1 over 9, I need a denominator of 36 to work with these two. So I multiply this by 4, multiply top and bottom by 4, and that equals 1 times 4 is 4, and 9 times 4 is 36. So now I have a denominator of 36. And I wrote a minus. That should have been an equal sign. That's that. Okay, it should have been an equal sign there. Okay, and so it's 436. So plus 4 over 36. 1 plus 4 equals 5. So those two equal each other. All right. And you can always check your work by plugging back into the equation. Okay, that takes care of it. It's the last assignment before the break. Use the break to get caught up on back assignments. And I'm going to have a special deal for you in class that I'm going to announce in class today. That's it. So get assignments done, get this one done, and we will see you all in class. Have a good day. Have a good holiday if I don't see you in class.